Hey everyone, so for your async work today, you're going to be looking at some compound interest examples. It's a really useful skill to work on because it's something that'll come up in your daily life. So, sweet. So here is our compound interest formula. We'll look at this more in class, but this is the basic idea, and it looks a little complicated. But all we have to do is identify the right variables and plug them in the right place. So let's take a look at what we have. A stands for the amount. So it's going to be our answer, the amount after so much time. P is our principal. That means the starting amount. R is going to be our rate. We want to make sure that we're using that rate as a decimal. And T is time, and we do time in years. And then N is what's new here. This is what makes this a little bit different than our exponential model that we've seen before. N is the number of times that we compound per year. Basically, how many times do we recalculate this interest? So this is really a really important note, because even though we're getting about a 1.5% annual interest rate here, that interest is paid every month, right? So that interest that's paid in January is going to make our account balance a little bigger so that we get a little more money in February, and so on. So it's important to take that into account, right? And it'll make a small difference at the end. Okay, so let's take a look at what we have and see if we can identify all of our parts. So we're going to put $9,000 into this account, and it has this rate of annual interest. We want to find our balance after 3 years if the interest is compounded monthly, and that's standard for savings accounts. They usually pay you your interest every month. Okay, so $9,000 is our starting amount. We call that the principal. So that's going to be P. Our rate is 1.46%. And we can't put in 1.46 into our equations. We have to turn that into a decimal. So percent means per 100. So we're going to take this number and divide by 100. So we get 0.0146. And we're looking for the amount of money after 3 years. So that's T, 3 years. And the interest is compounded monthly. So that means we're going to do this calculation 12 times a year. So we can see that N stands for how many times per year. So N is going to be 12. So we have all our variables now. Now we just need to plug it into the equation and do the calculations. So our principal, our starting amount, $9,000. You can think of this as your y-intercept. And then here we have our base. So we got 1 plus our rate, 0.0146, divided by 12. And we're dividing by 12 because we calculate our interest 12 times a year. And then that n goes in the exponent as well. We have n times t. So n was 12 and t was 3. Okay, so we've got everything plugged in, and now we have to do the calculations. You want to be really, really careful when you're doing these calculations because order of operations is going to be really important here. So we got to remember PEMDAS. So we want to take care of our parentheses first, then deal with the exponent, and then do the multiplication. So we're going to multiply times 9,000 at the very, very end. Okay, so we're dealing with some really small numbers. So when we're doing our calculations here, we want to make sure not to round too much. Okay, so I'm going to do my calculations in here, and I want to be really careful not to round. So I'm going to be writing down the steps as I go, but I'm going to keep all the information in my calculator here. So we said we need to deal with parentheses first, so I'm going to do that part first. And I want to make sure I get this order of operations within the parentheses right as well. So I'm going to do this fraction first, and then add 1. 0.146 divided by 12 plus 1. Cool, so we get this number with lots and lots of decimals there. And like I said, I'm going to round off a little bit when I write, just because I don't want to write all that information. But I'm not going to round in my calculator. And then 12 times 3, we can go ahead and take care of that. It's 36. We're going to erase this to the 36th power. Okay, so again, I didn't write down all these decimals, but I'm keeping them in the calculator, right? I'm just going to work from this number, and I'm going to go ahead and raise this to the 36th power, right? 36 because it's 12 times 3. So to the 36th power, and I get this number. Sorry, I'm moving this over here so I can read it and write at the same time. And you can use whatever calculator for this, but again, you don't want to round. Keep all that information in your calculator, even if you don't have to write it all down. So again, we have a ton of decimal points here. I'm just writing down the first few, just because I don't want to write it all. Okay, so it's this number times 9,000. It's going to be the last thing we do. And there's our answer. So the final amount after 3 years, $9,402.71. $9,402.71. Yeah. Okay, cool. I'm going to throw a dollar sign on this, and we are finished. So we put $9,000 into the bank. The bank was offering us 1.46% annual interest, compounded every month. So every month we got paid that interest amount. And then after 3 years, we've basically got our $9,000 initial dollars plus $403 of interest. So I hope this helps you work through these problems on your own. These can be a little intimidating, but it's just about carefully placing things into your equation, right? Your basic equation, and then making sure you're careful following order of operations in your calculator. Let me know if you need any more help. Thanks, guys.